Okay, Algebra 2 fans, our topic for today is Unit 3-4, Radical Arithmetic. And what we're going to talk about is how you can add, subtract, and multiply radicals. We won't get to the division part today. So just addition, subtraction, multiplication. Before you start, let me tell you your Algebra 2 joke, or your joke of the day. Why is the sky so unhappy? And the answer is, it has the blues. All right, so when we're trying to add and subtract radicals, so let's start with that. Directions perform the following operations. So number one, 2 times the square root of 3 plus 5 times the square root of 3. We treat a radical like we treat a variable. So let's say this was an x, 2x plus 5x. Those are like terms, so you're allowed to combine them. We add the coefficients, 2 plus 5, and we keep the variable. Radicals are the same thing. To be able to add or subtract them, you have to have the same radical unit. Square root 3, square root 3. So all we do is we add the coefficients, and what we get is 7 square root 3. Now just to show you, if I take this on the calculator, 2 square root 3, and then plus 5 square root 3, I'm going to get a decimal. I get 12.12, so on and so on. My answer, anytime we do simplifying, you should get the same value. Okay, it's the same value, 12.12. Same value, just a different way of writing it. Okay, so it's like combining like terms. So you have to have the same radical, the index, and you have to have the same number underneath. So number 2, 7 times the 4th root of 2 minus 9 times the 4th root of 2. Well, again, it's like 7x minus 9x. So we subtract the outside numbers, 7 minus 9, we get negative 2. And then the 4th root of 2 does not change. Again, it's like a variable. You don't change the exponents or anything on the variable. Number 3, 4 times the cube root of x plus, that's a 1, times the cube root of x, so 4 plus 1, and what we get is 5 times cube root x. 5 cube root x. Okay, and that's as far as you can go. So again, it's like combining like terms. Now number 4, it changes a little bit. The square root of 12 plus 4 times the square root of 75. This is not a good form. I cannot combine these because the square root of 12 is different from the square root of 75. I can only subtract and add these if it's the same square root number. All right, but what we can do is we can break this down. We can simplify each square root and then see if that leads us somewhere. Square root of 12, I can break that down. That's 4 times 3. I'm going to do a factor tree. And then 4 is 2 times 2. So the square root of 2 times 2 times 3. Now, you may have noticed 4 is a perfect square. Okay, so 2 times 2 is really a perfect square. So I take that pair, that's a 4. The square root of 4, when I pull that out, just becomes a 2. So the 3 stays underneath. What I have, square root of 12, is the same as 2 square root 3. So now I simplified that. Well, let's do the same thing here with 4 square root 75. Now the 75 I can say is 25 times 3. 3 is prime. 25 is 5 times 5. Now the 4 is still outside. I'm going to rewrite 75 as 5 times 5 times 3. That's a product of prime numbers. And you'll notice 5 times 5 is a perfect square. That's 25. So I can take the square root of that. I'm going to pull that out. The square root of 25 is 5. So I write down that number one time. And then what I have on the outside, 5 times 4 is multiplication. So it's positive 20 square root 3. Now you have the same radical number, root 3 plus root 3. So we take the 2 plus the 20, and we add that up. We get 22 square root 3. That's it. That's as far as we can go. Okay, what I'm going to ask you to do here is go ahead and pause the video. You do 5 and 6, and then come back and see if that's what you get. Okay, so I'm going to break this down. Square root of 8, square root of 18, square root of 3. So let's see if we can simplify this. Square root of 8, that's 4 times 2. And then 4 is 2 times 2. So we got 5 square root 2 times 2 times 2. I'm looking for a pair to pull out of a square root. 2 times 2 is a perfect square. That's 4. The square root of 4 is 2. So that's a 2 out there. 10, 2 times 5, square root, and then the 2 is left over. All right, so that's good. Now let's take square root 18, 2 times 9, and 9 is 3 times 3. So let's see, we've got, that's a minus 3 square root, 3 times 3 times 2. Again, we're looking for a pair of numbers that are the same because 3 times 3 is a perfect square, 9. The square root of 9 is 3. Now I'm going to multiply what's outside. That's 3 times negative 3. That's minus 9 square root 2. And then the square root of 3 is still the square root of 3. That doesn't change. Okay, now be careful. We can combine, we've got 10 root 2, and we have minus 9 root 2. We're allowed to combine those, but the square root of 3 is different. We cannot combine with the square root of 3. So we'll do 10 minus 9, and what we get there is 1 square root 2, or just root 2, and then plus 1 square root 3, which is root 3. That's as far as you can go. So it's possible you may have 2 terms or 3 terms when you're done. You combine what you can, and whatever's left over stays like it is. All right, number 6. Now x times the cube root of 4x. Cube root of 4x. Now I can break the 4 down and say that's 2 times 2. But to do a cube root, to simplify that, I need to have 3 of that number. I only have 2 2's. So it looks like x cube root 4x doesn't change. That's going to stay like it is. All right, so now over here, though, 32, let's break that down. I'm going to say 4 times 8. Then 4 is 2 times 2. And then the 8 is 2 times 4. And again, 4 is 2 times 2. So what I've got there is the cube root. We've got 2 times 2 times 2 times 2 times 2. We have 5 2's. And then x to the 4th is x times x times x times x. I can pull out perfect cubes. So in other words, this time I'm looking for groups of 3 that are the same. So there's a group of 2's. 2 times 2 times 2 is 8. The cube root of that is 2. X times x times x is x to the 3rd. The cube root of x to the 3rd is x. So on the outside, what I've got is 2x, and it's going to be minus 2x. And then on the inside, we have the cube root of 2 times 2 is 4, and we still have the x, so that's 4x. Now notice that what happens here, we have cube root 4x, cube root 4x. So that means that in this case, we can subtract the coefficients. That is a 1x minus a 2x. So 1 minus 2 is negative 1x. I'm going to say negative x times cube root 4x. That's our answer. That's as far as we can take it. So when you're doing this, if you can, break down the radical. If you have the same radical, same numbers and variables underneath, then you're allowed to combine the coefficients. But you don't change the radical part. All you do is you copy it. So that's addition and subtraction. So now what happens when we multiply? So let's start square root 6 times square root 6. If I do that on the calculator, so square root of 6 times square root of 6, we get 6. Interesting. Square root of 6 times square root of 6 is just 6. How about the square root of 105 times the square root of 105? Square root of 105 times square root of 105. Enter. 105. Interesting. Get the same thing. So it looks like that what happens is that when you multiply a radical times itself, you're going to get that number. And the reason that's going to happen, number 9 is a little different. When you multiply radicals, what we're allowed to do is write that as one single radical, and you can multiply the two numbers underneath. So I can do 2 times 7, which is 14, and that's the square root of 14. I can't break that down any further to simplify, so that's as far as I go. Going back to number 7, the square root of 6 times the square root of 6, you could say that's square root of 6 times 6, which is 36. But hey, that's a perfect square. I can take the square root of that, so I say that's equal to 6. And I'm done. Same thing here with the 105s. One other thing that will happen, okay, I'm just going to write it on the side here. If I took the square root of 7 and I square that, now that means you multiply it by itself, all you're going to get is 7. The square root of 122 squared is 122. Okay? Now, number 10, square root of 6 times square root of 2, well, that's the square root of 6 times 2, which is 12. Now, before I stop, I want to check and make sure that I cannot simplify. We can break down the 12. You could say, okay, 2 and 6, and then 6 is 2 and 3. Now look at that. We've got a pair of 2's. Square root 2 times 2 times 3. 2 times 2 is a perfect square. That's 4. The square root of 4 is 2. So I pull that out. I still have the 3. And my answer is 2 square root 3. And again, you can check. You can do square root 6 times square root 2 and get a value. Type your answer, 2 square root 3, and see that you get the same value. Number 11, cube root of 16 times the cube root of 4. So cube root of, I'm going to multiply the 16 and the 4, and I get 64. Before you start to do a factor tree or break it down, first ask yourself, is that a perfect cube or a perfect square or whatever it is? And in this case, yes. The cube root of 64 is actually going to be 4. So without having to do the factor tree, you can save yourself a lot of time if you recognize, hey, that's a perfect cube. Now, if it's not, then you go through and you do your tree, and then you simplify it. All right, so let's look at the back here. And all right, so we'll take number 12. You have the square root of 2, parentheses, 4 plus square root 3. You're going to distribute this. The thing about the arithmetic here is we're treating this just like we treat variables. The process doesn't change, it just looks different. So I'm going to do square root of 2 times 4. Now 4 is not under the radical. So when I write this, I'm going to put the 4 in front and then square root 2. That's 4 times square root 2. That's all I can do with that. It's not 8. It's not square root 8. It's just 4 square root 2. Plus the square root of 2 times the square root of 3. Now those we can multiply. They're both radicals. So it's the square root of 6. At this point, ask yourself, can we combine those? And the answer is no. The square root of 6, there's nothing you can pull out of that. These are different radical numbers. So that's it. That's all you can do. That's as far as you go. Number 13. We're going to do square root of 3 times 2 root 3. Now, the 2 is not going to change, but root 3 times root 3 is square root 9. Now, you may look at that and say, wait a minute, that's going to be 3. Root 3 times root 3 is going to work out to just 3. And that's fine. You can do that. So we get 2 times 3. That's going to be a 6. Then we distribute here. Minus 5 is going to stay the same. And this will be square root 3 times square root 2, which is square root 6. Now you can't do anything with that, so our final answer is 6 minus 5 root 6. And that's as far as you go. Now real quick, if I want to check it, square root 3 times 2 root 3 minus 5 root 2, close parentheses. I get a decimal value. I get negative 6.24. My answer is 6 minus 5 root 6. I should get the same thing, and I do. That tells me that this is equal. So that's the end of part 1 of the notes. Go ahead and stop and then move to part 2.